one over there.
Yeah. All right.
A code 500.
So has everybody got their study guide out?
I want 500 with
Yes, we need
100,000.
one.
500,000.
Nobody needs one.
Sure.
Everybody got one. Oh, you.
That's you as well, Levi. Tear you on.
That's fine. Yeah. All right. So
Thanksgiving.
we do have our study guide. Remember, guys, your finals. Your finals just a accumulation of everything that we've talked about this semester.
Everything.
That should be easy to know. Okay. We're gonna go over this today. Answer any questions. If you're confused about anything, you don't know, or you thought it was one, but it's actually another way, guys, this is the opportunity for you to ask us or ask me questions, okay? So, I know that you guys have been working on this, or you should have been working on this throughout the week, as you were finishing up your projects and everything, but please take this time to ask any questions. I'm gonna try to go over it, question by question, so that we'll be good. Yeah. What? You need one? Okay. All right, first question talks about what's the difference between light, I think, light waves and sound waves. What do you guys think?
I do. I think the sound wave has a medium and a light wave doesn't.
Perfect. Everybody got that? Am
Yeah.
I confused with that?
No.
Yeah, light waves does not need a medium. That's an electromagnetic wave. Okay? You don't need anything to create a light wave. All right? Sound is mechanical. Sound is mechanical. Okay? You need to do something for sound to be generated, be made. Everyone good with that one? Questions? Should be pretty easy. All right. When the frequency of light increases, the energy blank and the wavelength blank.
The wavelength increases.
Decreases.
The wavelength decreases, you said?
I
What about
said increases.
What's the frequency?
The frequency
Or the energy, my fault. What does the energy do when the frequency of light increases?
decreases. Decreases.
The energy of light will increase. You ever turn on a light and it gets
Oh.
brighter and then it feels hot? Okay? And the wavelength does what? It's all both. What? Why are you looking at me? What did you
What did you
say?
say?
The wavelength will decrease and the energy increase. Everyone good with that? Questions? Sweet. All right. Why do you think your friend can hear your music when you're listening? It's too loud. It's too loud? Okay, it's too loud. But
Because
what's
of the
making it
sound
loud?
waves.
Sound, hey,
Vibration.
the sound wave.
Vibration, sound wave? You said me?
Yeah.
Why do you think that?
Volume of the,
I like that word. Okay, the pitch, the volume, the frequency, all of that has something to do with your music being really loud. You're changing it, right? You're changing its frequency. You're making it louder, you're giving it louder. Okay? Now, when you're looking at that picture with the graph, we've talked about this. A lot of you guys kind of struggled with trying to figure this out when we took this test a long time ago. How to find the amplitude. What is amplitude?
Distance from the equilibrium expressed.
The distance from that middle, that equilibrium line, to the highest point, or the distance from the equilibrium line to the lowest point. Okay? So what would be the amplitude in this picture?
0.2.
Where, what?
0.1.
Where you get point two from?
You said it was 1.
No. If you're going from the middle from the top to the bottom, now you're talking about something else. Okay? We just want to talk about how high it gets. So yes, it's going to be 0.1. Okay? Now, number 5, I want to talk about how to find the wavelength. What is the wavelength here?
Oh, I know. Wait. I forgot how. Okay, wavelength equals frequency times.
Come on.
Yeah, you need to know the formula.
You need to know that formula.
I would just memorize the basic formula and then plug in what you get.
Maybe
This
it
one?
was times.
We'll give you formulas, guys, don't worry about it. But for this, what is the wavelength? How many waves do you have?
Four.
Okay? Is it 4? How much distance does it cover? So what math do we have to do with 4 and 6?
All good?
What you saying? What? I'm not worried about the speed right now. Pay attention, we're not worried about the speed. We have,
are you on?
we have the, number of waves and we have the distance traveled,
Fine.
okay? So we're gonna do 6 divided by 4. What?
6 divided by 4.
Frequency divided by,
60 divided by
no, 6.
Frequency divided by.
Divided by how many number of waves you got, and that will give you your wavelength. Because your wavelength can't be longer than the distance it traveled.
What was that issue?
So it's 1.5.
There you go. 1.5 times 4 is 6. Yeah. Everybody got it? Again, you're going to count the number of waves you have. So 1, 2, 3, 4. Okay. You get that number, you take the total distance traveled and divide by the number of waves you got. That's how you find your wavelength. Okay? All right, number 6. People still get that confused.
Oh, I got it.
All right? So, 2 waves are shown. Which one, or what's the difference in sound?
Okay, so the one on the right is louder, but the one on the left has a higher pitch. I think.
Okay? Talk to me about the frequencies.
Oh, this one has a smaller frequency.
This one?
Uh-huh.
Hey,
So this one has a
doctor,
larger.
which one has a higher pitch?
No, that one has
The
a
one on the
larger
left.
amplitude.
The one on the left has a higher but lower frequency. If that makes sense. The right has a louder.
I didn't catch none of that.
Oh, listen.
All right, let me start from the beginning. Which one has a higher frequency?
The one on the right.
Frequency.
No, the one left.
What is frequency?
How often?
How many times it happened, right? So which one has a higher frequency? Left. Which one has a lower frequency?
Right.
Okay, which one is louder?
The right,
One on the right. Why?
because it has a higher amplitude.
Because it has a higher amplitude. Everyone got that? Okay, which one is quieter? One on the left. Which one has a higher pitch? Why? Because of the frequency. Everybody got that?
Yes, ma'am.
What? So again, what sounds will you hear? This is it's really high pitch, but it's low, kind of soft, like a, not like a baby scream. And this is like somebody with a really deep voice just speaking loud. Okay? Everyone got that? Any questions? Please don't mix that up. All right. Going back to sound, the frequency of sound changes. What do we hear? Or what changes in sound when the frequency changes?
Pitch.
The pitch. You ever check the radio station? Everybody with me? Okay. When the frequency of sound changes, we hear changes in pitch. What about light?
Color.
No, the brightness, sure that.
And then you said the brightness, you said the color. Who else said color?
Color.
Okay? When you change the frequency of light, yes, color. Okay? The color. Now talk to me. Sound travels fastest in what? Light travels fastest in what? Light travels faster in the vacuum? What's a vacuum? Like outer space, okay? Sometimes we say vacuum, people are like, you the one that you... No, we're talking about outer space, okay? What about sound? Sound travels faster than what? A solid, right? That moves pretty easy. All right. Sound travels slowest in what?
Vacuum.
A vacuum. That's why you can't hear the sun. Okay? If you can hear the sun, it'll be really loud. Because of all the nuclear reactions and all that stuff that's going on there. What does light travel slowest in? A solid. And if I have my hand up with a light, you can't see it, okay? Alright, now, we're talking about finding the wavelength. Remember, we're going to give you the formula.
2 out of 30.
So, what is the wavelength of the sound that has a speed in air of 330 meters per second and a frequency of 990 hertz? Anybody want to come and answer this right now?
Do we have to divide?
What? What's the formula?
No, we have to multiply.
What's the formula?
Wavelength
Obviously, it's not
equals
gonna bring you
3.
above a C. Right?
Oh, anybody else?
Wait, 3 equals velocity.
Speed or, we don't want to use speed.
Okay, alright, well, good.
You got the formula, Drew?
Nice to have you as a student. Good luck.
Alright, velocity.
Distance over time.
That's another thing. There we go. Okay, velocity equals velocity. Hey, don't lose me now. Velocity is wavelength times frequency. Okay? Now who wants to come try it?
Me.
You didn't participate. I want somebody else.
You said what?
Let's go. What? You're gonna have another shot one day down the road. I know you did.
Yes. Yes, what time it is?
Okay. Yeah. Put shot here. Put shot here.
Yes. It was hard.
What you get? What you get?
Fred, you doing that at 10? You doing that at 10? Final draft? You can do it at 10?
I got the calculator.
I'll go to right over there.
You have to divide. I got the
Oh,
double.
you don't have to be in color?
Wow, Jerry.
Listen,
You don't care?
don't worry, we're gonna talk about it. What we get? You got that?
See, I said, ain't nobody was talking about the
I'm gonna do it in color. If you do that's extra points already. I'm not doing it. Oh,
All right, so let's look at this. So, thank you. Okay, so you did. All right, so velocity equals wavelength times frequency. You got a velocity, which is 330. Hey, listen.
Someone break my hand.
Here. You need
I don't need one, I just wanted to see what it looks like.
All right, listen, guys. I know you guys. Some of you guys are kind of confused. And you're looking at senior finals. We got this one wrong. So we know if we use the formula, velocity equals wavelength times frequency. What's the velocity?
330.
330. So 330 equals what's the wavelength? We don't know. We don't know. Let's ask, what is the wavelength? Times the frequency. What's the frequency?
990.
990. Going back to regular old algebra stuff. What do we have to do?
divide.
What are we dividing by?
990 on both sides.
990. Okay? So we want to get it away from the variable. So you're wrong right here, Vicente, okay? Vicente,
Jared.
Jerry, okay? My fault.
Jared is Daria.
So we got to do 330 divided by 990.
You did.
So what's the answer?
0.33.
0.3, whatever. Okay, so the frequency equals 0.3. My fault, the wavelength. My fault, the wavelength. Any questions on that? Make sure, listen, make sure you set up your formulas right. Even in math class, you can do all the math, but if you put a variable in the wrong spot, or you do the wrong kind of division, especially with algebra, if you do the wrong thing, It's gonna be wrong, okay? It's not gonna work out for you. So make sure that you set it up right, and make sure you divide the right numbers.
Now go to the bathroom.
Yes, ma'am. Any questions on that?
Get this shit out.
All right, let's go to the next one. All right, so we're talking about the law of reflection. What do you guys remember from that? Nothing.
I found some stuff.
What?
I know more than Terrell.
Bounces back.
Yeah.
What'd you say? What do you guys remember from the law of reflection when we talk about mirrors? Huh?
An angle.
Angle? Okay, that does have something to do with it, based on the angle the light comes in. Hey, what else you got to talk about? Or remember from reflection or mirrors?
Reflections, like concave and
Arcade, convex type mirrors, yes? What else? Anything else? Alright, so that's part we're going to do right now. So which one of these lights represents reflection?
see,
C? Why would you say C?
it bounces back.
It bounces back
At an angle.
at an angle? Okay. Is it the same thing on one side as on the other side?
Yeah.
Yes, because if we treat this like a mirror, it's going to bounce and come back, right?
Oh my God. What answer
Okay, we already know. Like this one,
is this? Help trying to-
listen, this is not reflection, that's just passing through, okay? It's just passing through like if this was a window, okay? This, where have you seen an example of like this?
Water. Like
When you
bend
put
the
something in water, right? When you stand in a pool and you see your legs over here, but your body's right here.
Yeah, like when you.
That's what's that called? Who remembers?
This.
What?
Diffraction.
Not diffraction.
Refraction.
Refraction,
I said
okay?
it first. Yeah.
We know it ain't that one, okay? So it's gonna be C. Everybody good?
Yep.
You guys are smart. All right. This one. Again, another one that a lot of people kind of got wrong when we took the first test. If you put a red flower with green leaves under a light with only green light, okay? This is what this is asking. Oh.
The red flower was
You put the red flower with green leaves under light with only wavelengths and green rings. In other words, it only has green light shooting at it. What color will the flower, the red, what
Black.
color will the red look like?
Black,
Why would it look black?
because it's a
I
green
don't
light.
understand. I just know this because I've seen it.
Well, what do you do? Why do you wear white or bright colors in the summer?
Because it's used for heat.
Keep
It's
cool, what? Not absorbed, it reflects. So the brighter the colors this summer, that's why you see people wear bright colors in the summer. Okay? When you wear bright colors in the summer, you reflect in light. What do you wear in the wintertime?
Black.
Darker colors. Why?
Keep you hot.
So you can stay warm. Okay? So it's still kind of cool this morning, I can tell, because everyone's wearing a dark color for the most part. You guys are trying to stay warm-ish. But when you go outside and it's hot, you're going to take off your jacket and you're going to have like a white t-shirt on. Who got a white t-shirt on? Yeah. But everybody understand that. For this one, that flower is red. That flower is going to do what to the light? Absorb it. Okay? And it's going to reflect black. It's going to reflect that color back. That's what's going on. So yes, the flower is going to be black. What about the leaves?
green.
Stanley,
Well,
what about the leaves?
they gonna be green.
Why would they be green?
Because the light was green on the green leaves.
Because green on green, give you green. You got to spend money to make money, right? Everybody good?
What after?
All right. Another one talking about wavelength. So Trey, you want to do this one? Wave has a wavelength of 15.75 meters. The frequency is 1850 hertz. What is its speed? Same formula. Okay. Once you guys will work on that, Trey, come up.
Oh, I'm doing my work.
Once you guys will work on that, I'm gonna come around and check it.
Make your handwriting on the side. Don't put like 200.
Oh, yes.
What?
I mean,
Keep on playing with us. suggestions about it.
Y'all not working on the question? That's why I need you to do it.
You gotta start.
You gotta calculate, and you got the formula.
You can feel some that way if you're messing with this. Terrell don't know what he's doing.
Yeah, he does.
Oh, for what?
Let me see.
So he get
You almost got it?
She said you don't like me. Yeah.
What we got, what we got, what we got? What we got, what we got?
9,
Who said?
Did though.
20?
Ain't no coming back.
200, no, 29.
What you doing?
Nothing, do anything. I didn't do
You
nothing.
got five.
Where, what school he go
You
to?
got five.
Where you getting around? Hey, Flash, don't get too distracted. All right, so, looking at the formula. Y'all with me?
Yes, sir.
Looking at the formula of the question, what is given to us? What's given?
He just want mine.
Wavelength, and then frequency, yes?
Doesn't matter. I'm not coming up front about it.
Y'all with me over here? Pay attention. Stanley, stop playing with the cards.
I forgot.
All right, so we're given wavelength and frequency, yes?
Yeah.
All right, what is that going to tell us what to do based on this formula? We're going to multiply. Wavelength and frequency are side by side. Side by side, you multiply. Wavelength and frequency, multiply. What's the speed that we got? What speed did you get? Or its velocity? 29,137.5. What's the unit for velocity? Or speed? Meters per second. Any questions? Any questions? Good job. All right. Who want to talk to me about this one?
I don't. Terrell?
You said? I think I heard you right. Hey, listen, listen. Hey, listen. What happens to the water waves as they pass through the opening? Well, we know that this is what's going on here?
Diffraction.
Diffraction. Okay? What happens to the waves? Are they still coming flat?
No, they
Get a ripple effect? Okay? That's going to go from like a small wave to a big wave? Right? It's covering a lot more ground.
Say it again.
What's happening to this wave?
Say the ripple.
Sandy,
Yes, sir.
please pay attention. All right, so we know the wave is it's a big wave, it gets to this wall. It's kind of like music. Remember when I gave you guys the example? Have you ever like walking down the street and you go into a party or something and you kind of hear the music, but then when you get in front of the door, it's loud?
Yeah.
Okay? This is kind of what's going on here. All right? The wave on the other side of the wall, I mean, it's coming, it's hot, right? Big waves coming through. But then, once it gets to that small opening, it's going to be focused. The waves are going to go really in that one direction. Is it going to spread? Yes, it's going to spread. But if we're talking about sound here, where is it the loudest? Right in front, right? It's the loudest right here in front. It's quiet on the outside. So I have a bigger wave, heavier wave coming down the middle. Now, outside I'm on it, I'm kind of safe. You're not going to have too many waves. Okay? Any questions?
Can I answer the next one?
Sure. How about you tell the class what? I'm not going to say nothing.
For real?
Go ahead.
this is an example of refraction, because the straw, it bends, like, it bends, you know, when we put it in the water, it bends,
Why does it bend that way?
because of the water.
What about the water?
Light passes through the water.
Fast or slow?
Um,
There you go. Okay,
so it's an example of refraction.
okay. That's right.
Is
Yes. No, no, no. No, shouldn't be.
no, we leave early because of the tablet.
Okay.
We leave in 3 minutes. Oh, we leave in 3 minutes.
Nobody's right now.
We leave right now?
Yeah.
Oh.
Thank you, good job. That's refraction, okay?
So we gonna be in third period,
Third period.
9:35.
Two or three?
For a while.
Yeah, third period.
Hours?
That's